Bismillahirrahmanirrahim. In this session, we will discuss exercise 9.5 from the topic of trigonometry from additional mathematics course IGCSE and O level students. And in this exercise, we will draw some graph of trigonometric functions from 0 to 360 degree. And we have a to f I. Here we have tangent x, cos 2x, and similarly the other functions. Let's draw this, and we have to find the range, its minimum and maximum value. So for this tangent x, the range is greater than 0, and it starts with the 0 and leads to infinity. So the range is 0, greater than 0, equals to and greater than 0. For second, cos 2x, it range for modulus value is 0 to 1, because cos function varies between -1 to +1. So here the coefficient is 1, so its modulus value will always be positive. So the minimum value will be 0 and the maximum will be 1. For 3 sin x, the value ranges from 0 to 3. For sine half x, 0 to 1. For 2 cos half x, 0 to 2. For this, because of this 2, and this value always gives a positive value. And similarly for this one, 0 to 2. For this value, we have this +1 to 3, because it always gives a positive value. For negative -1, this will be +3, and for 1, this will be -1, and that will be appear as a 1. So for this one, this is the value, and this is very important, and we draw this from the first one. This we will draw all this in a using some software. Fx is equal to tangent x. This is leading to infinity at 90 degree, and from -90 it reaches to 0 at 180 degree, and from 180 degree to 270 degree it always goes to positive infinity, and from plus 270 it will leads to 0 at 360. So this is simple tangent x, and if we take the modulus, this negative value will be positive. So this negative part will be positive, and this negative part will be positive. So this is the tangent modulus. The positive part remains positive. This positive part, well, this negative part becomes positive. Similarly, this one. In the second part, we have cos 2x. This is plotted between this, and for modulus value, this negative part will become positive, like this. So this negative part will become positive. So positive will be positive, and negative part will appear as a positive, and this positive part like this. So this is cos 2x, and its range can be seen as 0 to 1. For this 3 sin x, this is simply 3 sin x plotting, and for modulus value, this will be like this. This negative part will become positive. So this range is 0 to 3. This maximum value is 3, and the minimum value is 0. That's why the range is 0 to 3. For sine half x, this is the plot, and since it is positive, so its modulus will also be the same. So its range is from 0 to 1. For 2 cos half x, this is 2 cos half x is this. For this negative part, it will become positive. So its range is from 0 to 2. For 2 sin 2x, this is 2x. So this period is half here at 180 degree. The period will be 180 degree because of this 2x, because at 180 degree it becomes 360, at 90 degrees it becomes 180, at 45 it becomes 90, and value will come 1, and multiply by 2 to get this 2 value. Similarly for this negative part, for modulus value, this will negative part become positive like this. this negative part here, this negative part up here, upside, and in the positive side. And for sine minus 2x, this is intercept value, and here we have this from here to here. And for this modulus value, it will be positive like this. Similarly for this negative value. So here we can see this, the minimum value is 1 and the maximum value is 3 plus 3. So its range is from 1 to 3. Similarly for this sine x plus 1, this is the value. Here we have this 7 and here we have minus 3. But for this modulus case, this becomes positive. So this becomes positive from here to here. This is already positive, so that's why this. So this is simple sine 5 sine x plus 1. This is, and its range can be seen as from this 0 to 7. Similarly for this 4 cos x minus 3, this value is like this. For modulus value, it becomes positive like this. So its minimum value is 0 and maximum value is 7. Let's solve question number 2. Sketch the graph of 2 sin x minus 1 from 0 to 180 degree. Sketch the graph of modulus of this for 0 to 180 degree. Write down the number of solution of the equation 2 sin x minus 1 modulus is equal to 0.5 for 0 to 180 degree. So we will solve this. We'll plot this and then this modulus value, and finally that it will equate with 0.5 to give the number of the solution. So here we have this 2 sin x minus 1. So we'll plot it and finally we'll solve it. So here we have 2 sin x minus 1, simple plotting. This is intercept, so for 0 to 180 degree, because we are dealing with 0 to 180 degree for minus 1 to, so this becomes plus 1, and after taking modulus value, this becomes this, and this becomes positive. So we can see that its range is from 0 to 1, and since this modulus value is equating with 0.5, so here we have 4 solutions. One solution is here, this is a green line, and here we have 4 solutions, 1, 2, 3 and 4. So there are 4 roots. So this is simple. Question number 2, and